I just released an update to my big Next.js with Express and TypeScript course where we migrate the app we built there to the new Next.js app router. In case you don't know, the app router is a new way to build your Next.js projects and it replaces the older pages directory. The app router is built on React server components, which is a new feature in React. We will talk about server components in more detail later in this video. But when I first made this course, the app router was still in beta, so I decided to build a project with the pages directory, which has been stable for many years and will, by the way, also be supported for many years to come. So the pages directory will not go away, but I promised that I create an update for the course where we migrate this project to the app router. And the cool thing is, by building the project in the pages directory first and then migrating it, you really understand the differences between these two approaches and how they relate to each other. Both the pages directory and the app router can do the same things, but how we do these things like server-side rendering and caching is different between these two approaches. And knowing both approaches is of course also useful because there is still a lot of legacy code built with the pages directory, and some people even prefer using the pages directory for new projects now because the app router still has some problems. However, the app router has been stable for a while. The Next.js team had enough time to get rid of the biggest bugs and it's working quite well now. And I spent so much time building projects and studying the app router that I feel very confident that I understand how we are supposed to use it properly. In this video here, I want to talk about the changes I had to make to convert the project on a bit of a higher level. I will put a GitHub link in the video description below where you can see the differences between the project with the pages directory and the app router migration. So I put this GitHub page there and here you can see all the changes. We updated the packages and converted the whole project. And some of these files just moved to a new folder, they didn't change, but a lot of other files changed. So you can check out this GitHub link and see all the diffs. And if you want to check out the course, go to codingandflow.com/nextjs or nextjs.codingandflow.com. They both point to the same page. Here you can find the landing page of the course with the whole curriculum. And it's over 27 hours of content now. We built a whole blogging website with tons of features, with user authentication, our own backend server and a comment system and all this kind of stuff. And yeah, we built it with the pages directory first and then we migrate the project step by step to the app router. And here you can see the single steps involved. And yeah, in this video I want to compare the code and talk about the changes on a higher level. As you can see, the whole migration takes around 3 hours in total, but that's of course with explanations and everything. And when you take a look at the documentation of Next.js, you will notice that there is now this drop down here on the top left where you can select the app router or the pages router. The functionality, the stuff you can do in these two different routers is pretty much the same. Just the approach and how you write your code and structure your project differs between the two. But it's interesting to note that the pages and the app router are interoperable. You can have both within the same project. The only thing you will notice is that when you navigate between these two routers within your app, you get a hard refresh of the page. So it navigates like a real link, a real anchor tag, rather than a Next.js link, which maintains the layout and the navbar and everything. So it's almost as if you were navigating between two different apps, but of course it's still running under the same URL and you can share data within the same app. And Vercel already confirmed that the pages router will still be supported for several major versions of Next.js, which means several years basically. The Next.js documentation also contains this migration guide from the pages to the app router with some steps involved, but this is a very basic migration type. It doesn't cover quite everything you need to know, but if you read the rest of the documentation about routing and fetching and especially caching, then of course eventually you will understand the whole app router. But the first time you build a project with it, it needs some getting used to. But once you understand it, it's actually easier to use than the pages directory in my opinion, because a lot of steps to do server-side rendering and caching have been simplified, and generally you also have to write less code to achieve the same thing. Nevertheless, it can be a bit tricky, especially the caching part trips a lot of people up in the app directory, but in my Next.js course and also in the Next.js tutorials I have here on YouTube, I explain how caching works, so just check them out and this will help you understand this. The app router has been built around React server components, which are a React feature. This is not specific to Next.js. Other React frameworks can also implement these React server components, but as far as I know, Next.js is the only framework right now which implements these new server components. So Next.js is basically the only way to use this new feature right now. These server components are rendered on the server, so they have a similar purpose to what getServerSideProps and getStaticProps had in the pages router. So getServerSideProps and getStaticProps, they don't exist anymore in the app router. We will take a look at the code of such a React server component in a moment, but you can basically imagine them as a more powerful, but at the same time easier to use way to achieve the same thing as getStaticProps and getServerSideProps. The main benefits to what we had before is the smaller bundle size. Because these React server components are fully rendered on the server, no JavaScript of the packages you use in your code has to be sent to the client. Only the finished HTML of the page has to be sent to the client. Whereas in the approach we had before in the pages router, I think it still sent all the JavaScript to the client. Only the page was pre-rendered on the server. To be honest, I don't fully understand the differences between how exactly this rendering on the server works. I only know that server components are supposed to send much less JavaScript to the client, and therefore these pages load faster, especially on less powerful devices, and especially if we statically cache the page, so that all the data is fetched when we compile the project, and then we only send the finished HTML page to the client when they access them. Another cool feature is streaming. So in the old approach with getServerSideProps, we could load the whole data of the page on the server in advance, right? We loaded the data in getServerSideProps and passed it to the component. But this was an all or nothing approach. You had to fetch all the data that you wanted to load server side at once in this function. Whereas now we can actually segment our server components and say, okay, a certain part of the page takes longer to load, or maybe it's a bit slower to load than the other segments, but we don't want to wait for this part. So let's show a loading indicator instead. And then when the section has finished loading, we can load it from the server in hindsight or stream it in. This is why this is called streaming. It streams this result from the server to the client. But the content of the page is still coming from the server, which is better for SEO because this way search engine crawlers can see this content, and it also loads faster than loading and rendering this data client side. Besides server components, we also have client components. Now, since server components are completely rendered on the server, they don't provide any interactivity. We can't add click handlers in server components, we can't use state or effects in there, we can't use client-side APIs like local storage, we can't use context or any React hooks, because all these server components can do is loading and rendering components on the server and showing us the finished page, the finished HTML. Whenever we need interactivity, we can turn our component into a client component. We do this simply by adding this useClient, so-called directive, at the top. But it's just a string at the top of a component file. When you add useClient, everything below this directive turns into a client component. And everything you put into this client component is also a client component. Now here's the thing. In Next.js, these client components are still pre-rendered on the server. And in fact, in the pages router, all components were client components effectively. So it's not like client components are terrible for SEO. They are still pre-rendered on the server, they are still visible for search engine crawlers, and they can work and be rendered without JavaScript. But they are basically just a little bit less efficient than server components. They send more JavaScript to the client, they take maybe a bit longer to load, but this is the price we have to pay to get interactivity. Now by default, all components in the Next.js app router are server components, and you create smaller client components whenever you need them. So these client components are opt-in. You have to add this use client directive to turn a component into a client component whenever you need any kind of interactivity. And the idea is to create these small islands of client components to make only these parts client components. But again, you will see examples of this in a moment. Okay, let's just take a look at some code. And as I said before, the functionality of the website hasn't changed. In case you haven't seen this yet, in the course we built this blogging website where users can create accounts. They can write blog posts. We have a comment system with nested comments. So here I can write an answer. We have this nested comment. We even have pagination for these comments and the nested comments. We have this blog editor. In development it always loads a bit slow, but in production it's really fast. And here we can set a post title, we can upload an image to our server, we have user profiles and so on. So check out the course if you want to learn how to build this. But now I want to talk about the code and the changes we had to make to migrate this project to the app router. So on the left we have the project with the pages directory, and on the right we have the same project after the app router migration. The first thing you have to do to migrate from the pages to the app router is to create such an app folder, either in the src directory if you have one in your project, or directly in the root. Whereas the pages router is located inside the pages directory. And again, you can have both in the same project while you are migrating. You can have a pages and the app directory. And in the pages directory, we had this _app file, which is basically the root layout. This is where all the pages are rendered and where we can put common elements like the navbar and the footer, which should be shown on all pages, and also metadata that should be shown on all pages, or as the fallback if we don't set more specific metadata on other pages. And then we have this _document file where we don't really do anything. This is just some Next.js setup, basically. Here we have the HTML tag and this next script and this main tag, which are responsible to render our pages. In the app router, these two files go away, and instead they are replaced by this layout.tsx file, which is located directly in the app folder. And we need such a root layout. This root layout has the same purpose. We set the metadata here, just that it works a bit different. We put common elements like the navbar and the footer that should be shown on all pages. And then we render the pages themselves in here. And this is also where you put your context providers that should wrap all your pages. In here we also have the HTML and the body tag. So this replaces the _document file as well. And the _app file. To set metadata, we don't have this head tag here anymore, which we had to put into the return block in the pages router. Now instead we export this const metadata from the file. But I like the syntax more because this way we don't have to clutter our return block with this section which is not related to the UI. So I think this is much more clean. And whenever we want to render a page under a certain URL in the new app router, we have to create such a page.tsx file. And as you can see, I have quite a few of them because now they have to be called page.tsx. In the old pages router, we could either name our pages index.tsx, in which case they would take the same address as the folder they are located in, or we could put the name of the relative URL directly into the file name. For example, we could have a user.tsx and the URL would be root URL/user to show this page. In the app router, these files always have to be called page. They can't have another name, and we put the URL into the folder structure. So you can see we have this page.tsx directly in the app folder. That's the front page. And to create a page under /blog, for example, we create a blog folder and put a page.tsx in here. If we need dynamic URL params, which again in the pages router we put into the file name, we now also put them into the folder. So here we have, for example, blog. In here we have this square brackets slug folder, which creates a dynamic URL param. So we can replace slug for anything, and then we can receive this param on this page. So here this slug param is whatever we put into the URL after /blog/ and then the slug. As I already explained, all components in the app router are server components by default. So when we have a very simple component like this front page here, which only renders some text, then we don't have to do anything. This is a server component by default. It's completely rendered on the server, and yeah, we don't send any JavaScript to the client, only the finished HTML basically. Of course, it becomes more interesting when we actually fetch some data. For example, here on our blog post page, where we load all the blog posts from the database, or on the post page where we load a single post from the database. Let's take a look at this page, for example. This is under /blog/slug. This is what I explained a moment ago. This is our dynamic param. This can be different between different blog posts. And the page for this file is located in app, blog, slug, and then this page.tsx file. In the pages router, we had getStaticProps and getServerSideProps. Now that our components are server components by default, we can do something much more straightforward. We can turn the component into an async function. This is not possible in vanilla React, but it's possible now in Next.js 13 because this component will be rendered on the server. This means we can also just fetch data with async await in here and then use this data to render the UI. So we don't have this getStaticProps function anymore that we need to fetch data and pass it to our component. Instead, we do all of this directly inside the component now. Let's actually open the same file over here in the pages directory. So here we had pages/blog/ and then the slug param was directly in the file name, which now is not possible anymore. So getStaticProps is replaced by simply calling await getPost. This getPost function is up here. It just fetches some data inside the try catch block. You can ignore this unstable cache for now. I explained what this is for in the course, but this is not so important for now. And in the pages directory, we had getStaticPaths to tell Next.js which params we want to render at compile time. This is now replaced by generateMetadata, which has the same purpose, but again, this has a simpler API and a simpler return value. Here we had this weird return type that contains the object with this params key, and yeah, over here we just send the slug inside an object or whatever your dynamic URL param here is called. And by default, Next.js caches these server components statically, meaning that all the data for a page will be fetched when we compile the project. The server component will be rendered, but when a user opens the page, we don't fetch the data again. Instead, we serve them the cached page, which then loads really fast because it's just HTML basically. So this page here, a single blog post, is statically cached. So even if I now go into the database and change the title, for example, of this page and refresh the page, we would still see the same title because the data is fetched when we compile the project. Now, after we added a post, we also want to see the updated title, so we do something called on-demand revalidation. We revalidate the cache and fetch the data again without having to compile the whole project again. But again, I explain more about this in my Next.js course. So static caching is the default in a server component. We don't have to do anything special to activate this. We don't have to make this decision between getStaticProps and getServerSideProps anymore. Instead, if we don't want to cache this page, we can export another const called dynamic. And when we set this to force minus dynamic, this page will not be statically cached anymore. Instead, it will be loaded from the server every time a user opens the page. So this is the equivalent of getServerSideProps in the old pages directory. But in many situations, this here is not even necessary because often Next.js is intelligent about the caching behavior. For example, on the blog overview page, we have the page number as a search param in the URL. As you can see, a question mark page equals, and we read this value in our blog page, which is the page.tsx directly located in the blog folder. Here we read the search param, which contains the page number. This page is also a server component. As you can see, it's an async function, and here we fetch the blog post. But since we use SearchParams here, and SearchParams can only be known at runtime because Next.js doesn't know what search param or page number the user types in there, it automatically opts out of static caching and instead loads this page dynamically every time a user accesses this URL. So this has the same effect as getServerSideProps, which we used on the blog page before. With getServerSideProps, we always load the latest data from the server. We don't cache anything, but this is now handled automatically in server components for us, again by using the search params. If we didn't use the search params and we wanted to force this, again we could export const dynamic equals force dynamic, and this forces this page to be dynamically rendered. One more thing to note here is that we use this force dynamic export because we use Axios to fetch data in this app. If you use the native fetch function instead, so this normal fetch JavaScript function, then there's actually a newer configuration in here. In here we can set the cache, and here we have different options available. We can set this to no cache or no store. They effectively do the same thing. They have the same purpose as this force dynamic. They tell Next.js to not cache whatever we fetch with this fetch function and instead run it again the next time this page is accessed. But the problem is often you don't use the fetch function. You might be using something like Axios, or maybe you're using an ORM like Prisma, for example. And then we don't have this fetch option here available. In this case, we have these so-called route segment configs, which are these exports that change the caching behavior of this whole page. But again, we don't need this here because this page is automatically dynamically rendered. And I also left some explanation comments in the code. You can take a look at it if you want. Again, the link is in the video description. I already explained that we can set metadata like the page title and the description with this metadata export. But this only works for static metadata, like our hard-coded title and description here. If you need dynamic metadata that depends on some data, then you have to use another function for that. For example, on the blog article page, we have the title of the blog post as part of the page title, right? But in order to know this title, we have to fetch the data first. And you do this in this generateMetadata function here. This is how you can create dynamic metadata. Here we still return this metadata object in which we can set the title, description, and all these other kinds of meta information fields. Also the open graph image, for example. But here we can fetch the data first and then use this to generate these texts. Like here where I use the blog post title in the page title, the summary for the description, and the featured image URL for the OG image. Again, this all replaces the head tag that we had before. To be honest, the head tag was easier to use. This is a bit awkward here because we have to fetch the data again. But in return, we don't clutter our return statements. So I guess this is good. Now, when you fetch your metadata, there are still some things you have to keep in mind. You have to deduplicate these requests here so that we don't make this get post call twice. I explained this in the course, and I also explained this in my Next.js tutorials here on YouTube. So I don't want to go into more detail about this here. So definitely check out my tutorials if you want to learn more about this. One more thing that's interesting to note is that the default OG image and the fav icon are now files that we put directly into the app folder, and Next.js will automatically pick them up. So you put an PNG file into the app folder, and when you call it openGraph-image, when you give it this exact name, Next.js will automatically use it as the OG image for this website. So when we post a link on Twitter, for example, to this website, this image here will be shown. If you want to override the OG image dynamically, then you do this in generateMetadata, like we do here with the featured image URL. Let's actually take a look at this. We can use this social share preview page to try this out. I actually have this website deployed at the moment under coding in flow-sample.com. we should see the OG image, there it is, and the title and everything. And we should see a different one when we try out the URL for a specific blog post. Then we should see this title, this description, and this image here as the OG image. So let's try out this URL. And this works. So yeah, a lot of this stuff has been simplified, but at the same time it can become more tricky sometimes because the implicit behavior is not always clear. In the pages directory, everything was very explicit, right? We had getStaticProps for static caching, getServerSideProps for dynamic fetching, and now everything happens a bit more automatically. But again, when you wrap your head around this, then it works really nicely. One cool feature that helps you with this is when you compile the project. Let's try this out. Instead of npm run dev, we run npm run build. Wait a short moment until this project is compiled. Then we get this output here where we see these icons that indicate how each page is cached. So this lambda icon here, as you can see at the bottom, means the page is dynamically rendered. It says getServerSideProps, but yeah, in the app directory, it's now a dynamic server component. And up here we can see which pages are rendered like this. So the blog overview page is dynamically rendered, and some other pages like the edit post page, where we also always need the latest information, right? And these pages that have a dot are statically rendered, like a single blog post page, for example. But now let's also take a look at a client component. So for example, on the blog post page, this whole page is a server component because we want to fetch the data and render this page on the server, right? But when I go to one of my own posts, I have this edit post button here. And as I explained earlier, whenever you need on-click behavior, you have to do this inside a client component. But not only do we need on-click behavior, showing or not showing this button also depends if we are logged in with the user that wrote this blog post in the first place. And our user is fetched client-side as well. So when I refresh the page, we will first not see this edit post button, and it will then pop up after the authenticated user has loaded. So again, this means that even though this whole page is a server component, we have these client components inside it. The edit post button, but also the comments section, for example, because again, here we need click handlers, state, input, and so on, which are all client-side features. And as I mentioned before, we want to avoid making this whole page a client component if we can avoid this, because server components are more efficient. So let's take a look at the code of this page again. In the old pages directory, we didn't really have to pay attention to this stuff. We could just load the authenticated user in here and then decide if we want to show this edit post button or not. But in a server component, we can't use state or JavaScript anymore. But you can create these little islands of client components. For example, I moved all of this logic here into this edit post button component. The edit post button component has to use client directive at the top. So this is now a client component. And in here we load the user. And if the user is not authenticated to edit this post, we return null. So we don't return the button. We don't show the button in the UI. And again, this way, only this button itself is a client component and the rest is still a server component. And the same for the blog post comment section down here, which again has this use client directive at the top. And as I mentioned before, when we put use client here, then every component we use inside this client component is also automatically a client component. We cannot put a server component into a client component. That's important to understand. We can only put client components into server components because all server components have to be rendered before the client components are rendered. So when we use another component inside the blog comment section, for example, the create comment box, which is in a separate file, this component does not need the use client directive at the top. We could put it here like this, would have the same effect, but it's not necessary because the blog comment section inside which we use the create comment box is already a client component. And this trickles down to all the children nested inside it. Now, again, we can't put a server component into a client component, but there is one important exception to this rule. Remember that our context providers have to be client components, because in here we use client-side features like state or effects. But these context providers usually wrap our whole application, right? Including all our pages. Does this mean that every page is now automatically a client component? This would be pretty bad, because then we don't have any server components in our website at all. But the answer is no. In this case, we can put server components into our off-models provider client component, because we use this children prop to render components inside here. When we use this children prop, then Next.js doesn't have to know in advance what exactly we put in here. So it can still render all the server components. It can then render our client components, including the off-models provider. And then it can just take the already compiled server components and put them in here where the children slot is. So this works. What would not work would be something like this. Putting a server component directly in here, where this would be a separate component, but this could not be a server component, because again, then Next.js can't compile it in advance. But with the children prop, we can put server components in here. So we can have our context providers that wrap our whole app, and in here we can still put all our server component pages without a problem. But the context is only accessible in client components, because again, use context and all other hooks that start with the word use are client-side features. What's also cool is in the new app router, we can now collocate all kinds of files together with our pages. So we can put our CSS files, for example, in the same folders as our pages and other components as well. Whereas in the pages directory, I had all my CSS files in the separate style folder. So I like this here much more, because now it's easier to find the related files. And then there are also some other special file types that are explained in the documentation. So we have layout.tsx and page.tsx, right? And we have to give them these names. To show a loading indicator when we load a server component, we have loading.tsx. So here I simply show the spinner, and you can sometimes see it when I refresh this page or navigate to another page. Sometimes you can't. Yeah, there it was for a short moment. That was the loading indicator, the loading page. Then we also have not found, which replaces the old 404 page. And then we also have an error.tsx somewhere, which replaces the 500.tsx. So they have the same purpose. It's interesting to note that you can also have nested versions of these special files. For example, we could put a different error.tsx into our blog folder. So we would show this only on /blog pages. And we can even put a layout in here. So remember that our layout shows common elements between multiple pages. For example, our navbar and our footer that we want to show on all pages. We could add another layout.tsx into the app folder, and then we could create a nested layout here. So maybe the blog should have another navbar or a sidebar that we only want to show on the blog, but on all blog pages. Then we could create such a nested layout.tsx file, but here we only have this one. The root layout is the one you always need. So you always need this one layout.tsx in the app folder. I still have a separate components folder for reusable components that I use in multiple different places. One more thing to note is, in this project we use Bootstrap, because I find it easier to use than Tailwind for tutorial projects, because we don't have to write so many classes and it's easier to get a good styling working fast. Now, one problem with Bootstrap and similar component libraries and the new app router is that these Bootstrap components actually use client-side features internally. They use context, sometimes state, but the developers of React Bootstrap didn't add the useClient directive to the code of these files yet, which means that normally we can't use them inside a server component, because then the compiler complains that we didn't add the useClient directive to the top. But again, we don't want to make all our pages, like the front page, a client component only because we use these Bootstrap container components in here. But an easy way to fix this is what you just saw. We create our own file. Here I call this bootstrap.tsx, We add the use client directive here, and then we just re-export all these components. Now we turned them into client components. And again, as I explained earlier, whenever the children prop is used inside a client component, we can put server components in there. This is why we can have something like this, where we have this Bootstrap row, which is a client component, but whatever we put inside it can still be rendered on the server because it's rendered inside this children slot of the row or the column. But yeah, I explained this in more detail in my Next.js course, and in my Next.js 13 beginner tutorial here on YouTube, I also explained this Bootstrap approach in more detail. So check this out if you want to learn this. But some features are still missing in the app router, and people often complain about this on GitHub. For example, in the pages directory, we had this use unsaved changes warning hook. This hook would show a warning when we have some input here and we try to refresh the page. Then it would say, hey, you have input, you will lose this when you refresh the page. And we also made this work when we navigated within the app via these links here. The problem is we don't have these necessary router events anymore in the pages directory. So here we had this router events, route change started, and we could intercept this. This doesn't work anymore in the app directory. It's just not there anymore. So I had to find a way around this, but I replaced this for something cooler. I created this use autosave hook, which automatically saves our input between refreshes and between navigations and so on. So now whenever I type something in here, it's saved every 3 seconds automatically to the session storage, but you can also change the duration. And when I refresh this, the input is still there. Isn't this cool? It's actually cooler than what we had before. Again, the link to the GitHub code is in the video description if you want to check this out. Now, one more thing that often trips people up in the app router is the client-side cache. So even if our server component is dynamically fetched and rendered, like our profile information here, there is another cache on the client between navigation. So often people have the problem that they change some data on the server, for example. Let's change the display name. Then they navigate to another page and they navigate back, and then they see the old data again because this is cached on the client. But as you can see, here it works when we navigate back and forth, because in most cases there is actually a simple solution to this caching problem. Let's take a look into the update user profile section, which is a client component because we have input fields and state there. And after we updated the user information, we simply call router.refresh. Router is coming from the useRouter hook, and this completely busts the client-side cache. So all these cached pages are removed, the page is reloaded, and then when we navigate back and forth, we load the latest data. A few more things that are worth noting. Before we had the useRouter hook here, which is an import from next/router. This one does not work anymore in the app directory. Now we have to import router from next/navigation instead. And from useRouter we can also not get the search params and the path name anymore like we did before. Instead we now have separate hooks for them. So we have usePathname, useSearchParams and useRouter, and often you have to use them together. I don't know why they split them up, but they probably have a good reason. And API route handlers also look a bit different now. So in the old pages directory, we had our one API route here to revalidate a post on demand. We still have this in the app directory. Now these API routes have to be called route.ts or JS. And again, you have to put the dynamic URL params into the folder structure and not into the file name anymore. The new syntax of these route handlers is better in my opinion, because before we had this one handler function, and in here we had to check with an if check if it's a get request or a post request and so on. And now we have these separate functions. Get in all uppercase, for example. We can also export async function, patch or post, or the other HTTP verbs. And here we do the same thing as before. We revalidate a post after updating it, so that we render it again and then cache the updated blog post on the server for future access. Now, of course, I can't cover everything about the migration in detail in this video. Again, if you want to check out the updated course, go to codingandflow.com/nextjs and you will step by step learn how to migrate this whole project to the app router. And keep an eye open for future Next.js videos on this channel. And then I wish you a nice rest of the day. Happy coding, take care.